Okay, so now we're going to look at section 2.2, linear equations in one variable. I have it open to the textbook here, page 87. This is the PDF, but you could also look at it on the ebook online. One thing I want to point out too is that the assignment that I made, I changed it a little bit so that you really know to do both the reading and the videos. One you might lean on more than the other, but to be comprehensive enough, especially as we are going to get into some newer materials soon, brand new stuff for you. So I'm not going to read in the videos, I'm not going to read the same things or say exactly the same things that are in the textbook. So it is worthwhile. So for example, this first figure 1 that represents how Caroline is a full-time college. She's planning a spring break vacation. She's trying to get enough money for her trip. And there's a couple of different things going on here, that she has some money that she's got to get $2,500 to pay for the trip, and she's earning some money. How much does she need to work to get that? And then, basically X marks the spot here where they intersect. We have hours worked on the X-axis, savings account balance on the Y-axis, and so she's starting off, she has some money in the bank, and then she's working on this blue line going up, and it will intersect the cost of the trip at some point, so she'll know she has enough. So this is an important application of our linear functions. The 2,500 is a constant function or equation, and the other one has a slope of 15, so that's the rate of change. So those kind of things, reading through that, reviewing through that, you've probably seen these kind of problems before, as when you've done systems of equations before, and we will be hitting some more applications along the way, so just be aware of that and make sure you go through those. I'm going to switch over to my examples in the videos that are different from the book. They're similar and things like that, but there's also the vocabulary here that you should read in the book. So again, I really am not going to cover all those details in the videos because they are there in your book. They'll come up and I'll talk about them, but when you want to go back and study notes, make sure you get into the book, especially the review section. It has so much vocabulary. It's really nicely laid out for you. So I do have some directions written here too, and some procedures. This section talks about linear equations in one variable. Later we'll start to learn about functions, so sometimes I might say functions. Solving rational equations, they are not linear equations, but when you simplify them and clear the denominators, then they really, for all intents and purposes, kind of become like the linear ones in the way we solve them. So here's all the methods. I'm going to go through a couple of them, and I'll leave some for you to try. This will be a 2-part video set. So rational equations, remember, have polynomials in the numerator and denominator. And so usually we call it a rational equation if it has variables in there, but it could have numbers because constants are also considered polynomials. So given a rational equation, to solve it, we would, 1, factor all the denominators in the equation. Then we are going to find and exclude values that set each denominator equal to 0. So we need to find the domain. Find the LCD, which again is the lowest common denominator. Multiply the whole equation by, a little typo there, by the lowest common denominator. If the lowest common denominator is correct, there will be no denominators left. So make sure that you choose correctly. Even if you go a little bigger, it's better than not getting it at all. Number 5, solve the remaining equation. So it should come out looking like a linear equation. Make sure to, number 6 is make sure to check solutions back in the original equations to avoid a solution producing a 0 in a denominator. So you can check it against the domain, but sometimes you just want to do a check to make sure the sides balance. So I'll do this one. Number 1 reads x over 3 minus 3/4 equals quantity 2x plus 3 in the numerator, all divided by 12. So this is one with numbers in the denominators, no variables. So you should be familiar with this. So I'm going to look at 3, 4, and 12 and say what is the lowest common denominator of those. And really it's just going to be 12. So I want some number that all those divide into evenly without a remainder. So the LCD is 12. So I'm going to divide multiply everything by 12. So this is an equation, and that's why we can do this. If it were an expression, we couldn't do it, because we'd be changing actually the value. This, we're just getting everything to be a multiple of 12. Really what I'm doing is multiplying the entire equation by 12 and then distributing the 12 to every term. So this should be familiar ground. So then I'm going to reduce each of these fractions. So for the x over 3, that will become 4x. And then the 3/4, when I multiply it by 12, will become a minus 9, because that was a subtract. And then we have an equal sign. And then this 2x plus 3, be careful, you should put those quantities in a numerator or denominator in parentheses, because the grouping symbols aren't there, but they're understood that the numerator itself acts as a grouping symbol. So when you are doing this, you really need to add them in there. And then you're going to distribute the 12. Actually, we don't even need to distribute in this case, because we're going to reduce it, and we have 12 over 12, so that works out nicely. We just get a 1 there. So distributing a 1 is not going to affect much there, anything. So, but if it came out to be a different number, for instance, you would have to distribute. So here we're going to now just solve like you normally would. I ended up with 4x minus 9 equals 2x plus 3. So I'm going to subtract 2x from both sides. Leaves me with 2x minus 9 equals 3. And then I'm going to add 9 to both sides. And the 9's cancel. And then I am left with 2x equals 12. Divide both sides by 2, and you get x equals 6. Now, because I had all numerical values in the denominators, I didn't have any restrictions. All real numbers work, so that is fine for my answer. Now, using that same principle, you might like to try number 2 on your own, because that's a simpler one than number 3. I'll do number 3 step by step. I'll do both of them, but you might want to pause the video and do number 2. That is 3x in the numerator over quantity x minus 1 plus 2 equals 3 in the numerator divided by quantity x minus 1. So on this one, the lowest common denominator is x minus 1. So I'm going to want to multiply the entire equation by x minus 1 and distribute it. So when I do that, sometimes I just really write it out as, I'll take a little shortcut. I'm going to erase this stuff here that I wrote. And I would just write it as multiplying every term by x minus 1 in parentheses. So just be careful you don't miss any. Even the the whole number there needs to be done. So sometimes put things that aren't fractions over 1 so you don't forget about them. That's a little tip there. And if you had numerical values in denominators, don't forget about those also. So here we now have x minus 1 times the 3x over x minus 1, so that those x minus 1's will reduce down, leave me with a 3x. On the next term, plus 2 times quantity x minus 1, we have nothing to reduce, so we're just going to write that out as 2x minus 2. We're just distributing, then carry down the equals. And then on the right hand side we have that 3 over x minus 1 times x minus 1, and those will reduce down and leave me with just 3. And now just solve. Since it's a linear format here now, I would combine like terms. 3x plus 2x is 5x, minus 2 equals 3. Then add 2 to both sides. And then we get 5x equals 5, x equals 1. But then I have a bit of a problem here because I didn't set the domain ahead of time. It's usually a good idea to do that. But if you notice, the domain is actually all real numbers such that x is not equal to 1. So I'm writing this in set notation with braces around it. So I have like a brace, real number, like a double line R, that stands for real numbers, and then a straight line means such that, then x not equal to 1, and then I close it with the brace, that symbol's called. So if I end up with an answer of 1, then really the only thing I can write is no solution. That's actually my answer. So what I do sometimes is I make it real obvious and I cross out the answer and I write extraneous. So I know it doesn't fit the denominator. Okay, we're going to do one more for this video set, and then we kind of switch gears into writing equations of a line. This is sort of an oddball topic thrown in here, but I think they want to just review this skill. Number 3 reads, this is example 3, 5 divided by quantity x plus 1 divided by quantity x minus 3 equals -6, all divided by quantity x squared minus 2x minus 3, and quantity. So on this one, we want to factor first, and then we should figure out the domain first. That's really step 2, which we kind of skipped. I skipped last time. So sometimes these denominators will give you a clue how something's going to factor, but don't necessarily rely on that. So I'm going to factor the x squared minus 2x minus 3 because that's the only one I need to factor. The other ones are already set. So I would have x minus 3 and x plus 1. And those happen to be the same values I have in my other denominators. So my lowest common denominator is a product of distinct primes. So really I need to make sure everything goes into that LCD, which is going to be x minus 3, x plus 1. So I know that the x plus 1 divides into that because it's a factor of the LCD. X minus 3 is a factor of the LCD, and also the x squared minus 2x minus 3, it's actually the entire LCD itself. So all of those, when I simplify, will work to get rid of the denominators. The other thing I want to look at is what my domain is. So my domain is going to be all real numbers except x cannot equal 3, because if I have a 3 in there, right here, the x minus 3, then that factor would be a 0, and it would make my entire denominator 0. So I cannot have 3, and I also cannot have a -1. So if you haven't done much with domain before, how I'm figuring it out is I'm just taking each denominator there and setting it equal to 0 and finding out what my restrictions are. So I'm writing restrictions, and then x minus 3 equals 0, x equals 3 is a restriction. So that means really x cannot equal 3. So sometimes people like to write it as a little shortcut. You could write x plus 1 should not equal 0, right? And then solve out x not equal to -1. So we know if we get one of those answers, then we can't use it. So let's continue on with multiplying. Now we're going to multiply the entire equation and distribute the lowest common denominator. I'm going to take the little shortcut of just multiplying every term by x minus 3, x plus 1. So I'm just writing that in next to every numerator. X minus 3, x plus 1, x minus 3, x plus 1. And then I am going to now reduce. So in the first fraction, I would cross out the x plus 1 over x plus 1. In the second fraction, I'm going to cross out the x minus 3's, top and bottom. And then on the right-hand side, I'm going to cross out the entire thing. Make sure you catch all of that. So I am left with 5 times x minus 3 plus 1 times x plus 1 equals -6, and then I have nothing left to multiply there. So now I'm going to just distribute 5x minus 15 plus x plus 1 equals -6. And you could probably just stop the video and go ahead and solve that yourself. So I've written out the remainder of the steps. You would then get 6x minus 14 equals -6. And then add 14 to both sides. 6x equals 8. Divide by 6 on both sides, and you end up with an answer of x equals 4/3. Just leave it as an improper reduced fraction. Do make sure you reduce. We generally don't convert to decimal or mixed numbers unless it's an application problem. And usually I direct you on a quiz or a test, like I'll tell you how to round, and the homework usually does that too, if rounding is involved. And then I want to just check against the restrictions. So since my domain is all real numbers such that x is not equal to 3 or -1, I'm good. So that answer is just fine. So that's the end of part 1 of this video set.